Good morning again. Today, as you may know, because we have been together with a lot of months, for a lot of months, I'm not going to follow the order in the book. Today, we are going to start with the last part of the unit that is dealing with the characteristics of functions. And the part of characteristics of functions we are going to study today is the part of increasing and decreasing intervals. Increasing and decreasing intervals have been studied in your last year, so it's something that you may know. As you may know, a function, when it goes upwards, it is called to be increasing function, and when it goes downwards, it is a decreasing function. But remember that when I say if a function goes upwards or downwards, I have to look from the left to the right in the same sense that when I'm reading a book. Because if I look in this sense, this function is going downwards, and it's not what I'm trying to say. When I have an increasing function, imagine that I take two values of x. This is x1 and this is x2. This is the value of the function in x1, and this is the value of the function in x2. So, if the function is increasing, I can say that if I have two values of x, for the smallest value of x, I have a smaller value of the function. And for the biggest value of x, I have a bigger value of the function. And this is the definition of increasing function. What happens if I have a decreasing function? Again, I'm going to take a couple of values for x. This is x1 and this is x2. x1 continues being smaller than x2 according to that. But this is the value of the function for x1, and this is the value of the function for x2. You can see that now the value of the function for x1 is bigger than the value of the function for x2. And this is the definition of decreasing function. In our own words, we can see that in an increasing function, the bigger the x, the bigger the value of the function. And in a decreasing function, the smallest the value of x, the bigger the value of the function. Okay? In general, a function is not going to be all the time increasing or all the time decreasing. In general, a function will alternate intervals where the function is going to be increasing and intervals where the function is going to be decreasing. way, how I want it to write. The function starts here and ends here. Imagine I have this function. The function is defined from minus 10 to 19. I can say that the function is increasing, first of all, in this part, because it grew up until it arrives to that point. It is said that the function is increasing between the values of x. I don't have to mention the value of the function. So this function is going to be increasing from minus 10 to minus 4. Remember that this is a way of saying from minus 10 to minus 4. We have studied in the first unit. After that, the function becomes decreasing. Function is decreasing from minus 4 to 3. After that, the function from 3 to 9 is going to be increasing again. From 9 to 13 is going to be again, from 9 to 16 is going to be decreasing again, and at the end, from 16 to 19, it's going to be again increasing. So I have 3 intervals where the function is increasing and 2 intervals where the function is decreasing. What happens if, for example, instead of arriving to this point, function continues until 21, where it ends, continues horizontally. When I have a horizontal line, the function is not increasing, but it's also not decreasing. What I can say about this function? I can say that it's constant. Function is going to be constant from 19 to 21. Okay? But is there, apart from the definition I have given, is there any other way to say that a function is increasing or decreasing without drawing without having the graph or drawing it? Let's see. I told you, if I have x1 lower than x2 and it includes the value of the function in x1 being smaller than the value of the function in x2, it is an increasing function. According to that, if I subtract the value of the function in x2 minus the value of the function in x1, it should be a positive value. But of course, I should include that the condition is that x1 is smaller than x2. So, if this, I can say the function is increasing if this is positive, if x1 and x2 are placed in the appropriate way, in the same order as they are. So, if I divide by x2 minus x1, this is a positive quantity, and this is a positive quantity if the function is increasing. And this quotient that is defined this way is called the average rate of change between x1 and x2. And this is the definition. So, an increasing function will have average rate of change always positive. What happens when I have a negative and decreasing function? In this case, I told you before, this was a decreasing function. According to that, if I calculate the average rate of change, the denominator continues being positive because x2 is higher than x1. And if I have these two values of the function, when I subtract this minus this, as this is bigger, the result is going to be negative. So the average rate of change for decreasing functions will be a negative value. Okay? Let's see some examples with a function. The average rate of change has only meaning if I'm taking closer points. Why? Because remember the function I have drawn before, it has changing in increasing and decreasing intervals. If I take points that are too far away one from the other, I cannot say that there is a change of tendency or a change in the behavior of the function between the points I'm taking. Imagine I have the function x squared plus 3, and I'm going to calculate the average rate of change between 3 and 5. Okay? According to that, this is the value of the function in the final point minus the value of the function in the initial point divided by final point minus initial point. Let's calculate the value of the function. The value of the function in 5 is 5 squared plus 3. 25 plus 3, it is 28. The value of the function in 3 is 3 squared plus 3. 9 plus 3, 12. So the average rate of change will be 28 minus 12 divided by 5 minus 3, that is 2. 16 divided by 2, 8. The average rate of change between 3 and 5 is 8, so it's positive, so it is an increasing function in the interval in 3, 5. Okay? Okay? So let's do another example. I take a different function, a function 1 divided by x, and I'm going to calculate the average rate of change between 2 and 4. It is the value of the function in 4 minus the value of the function in 2 divided by 4 minus 2. The value of the function in 4, it is 1 divided by 4. The value of the function in 2, it is 1 divided by 2. So it is 1/4 minus 1/2 divided by 2. 1/4 minus 2/4 is minus 1/4. Minus 1/4 divided by 2 minus 1/8. So the average rate of change between 2 and 4 is minus 1/8. So it is negative, it is a decreasing function in the interval 2, 4. Okay? Related with the concept of maximum, of increasing and decreasing, it is the concept of maximum and minimum. When a function is increasing and after that decrease, there is a point that has a value of the function higher than the points around it, and it is called a maximum. When the function decreases and after that increases, there is a point that is below all the points that are close to it, and this point is called minimum. So, in fact, I'm just speaking about points that are close to the maximum or the minimum. This is the reason why I can have in a function more than one maximum and more than one minimum. In fact, we speak about the relative maximum and the relative minimum. In both cases, they are points that are respectively, the value of the function is higher than the points around, or the value of the function is lower than the points around. Let's see an example. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, where do I have a maximum? It's obvious that this point is a maximum. To say I have a maximum here, I have to give the coordinates of the point, not the value of the function, not the value of x, both of them. Not as in intervals. In intervals only I need the value of x. In intervals of increasing and decreasing intervals, only the value of x. In maximums and minimum, both coordinates, the value of the function, but also the value of x. So this point is 11, 8. It is obvious that here I have a minimum. A minimum in 3 minus 4 and a minimum in 17 minus 5. But what happened with this point and this point? According to the definition, as the function ends there, this point has a value of the function that is higher than the points that are around. So here I'll also have a maximum in minus 4, 8, and here again I have a maximum, but now the point is 24, 8. The 8 is 8 because I draw this way. It's not necessary for all the maximums to have the same value of the function. Okay? So this part of the unit is related with pages 88 and 89. This is the point number 5 in the book. So in the minutes you still have of class, you have to read pages 88 and 89. You have to summarize all this information with the explanation and the notes taken from the video. And after that, you have to solve the exercises in both pages 88 and 89. So exercises 1, 2, 3, and 4. And see you tomorrow.